Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, I'll just get started on this topic on stoichiometric and mole ratio by teaching you guys how to do formula and equations. So before this in the lesson, you would have access to a table of all the common cations and anions, and now given the name, you should be able to identify, like let's say sodium sulfate. It comes from Na plus and also SO4 2 minus. This is pronounced as SO4 2 minus. This is a sulfate anion. Between the cations and the anion, you have an ionic compound. So the structure between the two ions combining together will be giant ionic structure. So I'm just going to show you a couple of things here. The way we would do this, we can do it two ways. The usual way they do in book will be the crisscross method. That is, bring down the charge, plus 1 belongs to the Na plus, minus 2 belongs to the sulfate anion. Now you have to do the crisscross, so the minus 2 go there, but you only take the value. So here these are the charges. When we do the crisscross, we only take the numerical value. We only take the numerical value. So only numerical value. We only look at the value without the charges. And then you have to think, are they the simplest ratio already? Simplest whole number ratio. Are they in the simplest whole number ratio or not? And 2:1, it is in the simplest whole number ratio. So there are 2 Na plus. It means there are 2 times Na plus. In fact, I could have written it this way: Na plus, and 1 of the sulfate, so SO4 2 minus. And then you could also summarize them like this. There are 2 of the Na plus, so subscript at the bottom there, 2 of the Na plus, like this, 2 Na plus, and then SO4 2 minus, there are 1 of it, there's 1 of it, alright, and then we can further simplify it into without the ion form, so it's just Na2. I don't need a bracket because it's just one single atom. I also don't need a bracket for SO4 2 minus because I'm just going to show SO4 since there's only one of them there. There's Na2, SO4. When you pronounce it, sodium sulfate is Na2SO4. You could do this on a piece of paper where your workings could be a lot clearer. So I'm just going to show you for copper 2 carbonate now. Cu2 plus, CO3 2 minus. So there's copper 2 carbonate. So I did say earlier you can use the crisscross method, but there's actually another method that I should show you for sodium sulfate first of all, since that's what I'm interested in doing at the moment. We talk about this. The plus 1 is loss of 1 electron. Is formed as a result of losing 1 electron from the sodium atom. And this is SO4 unit has gained 2 electron. Altogether, there are 2 extra electron compared to the total number of proton. That's why there's a net negative charge. These are stated in the year 9 topic under chemical structure and bonding as part of what constitute positive ion, cations, formed as a result of loss of electron. This is negative ion, it's called anion, is formed as a result of gaining electron. Okay, so we could think about as LCM, which is lowest common multiple. This is what we do, but this is not actually the process that's involved. The process that's involved is actually transfer of electrons from the sodium atom. Loses, you need 2 of them, each of which loses 1 electron to the SO4 unit. Now you get SO4 2 minus. Alright, so what happened then is you have a plus 1. Actually, we look at the numerical value only. 1 electron loss, 2 electron gain. 1 electron loss because of the charges, 2 electrons gain because of the charges. 1 electron loss, 2 electron gain. What is the lowest common multiple? The LCM is 2. And since I did say this is an alternative method, you have Na plus and SO4 2 minus. This is the goal, this is the objective. You want to try and balance out the charges. So this is Na plus. How do you get to 2 electrons being transferred? You need 2 of them in order for the plus 1 to get up to loss of 2 electrons. This already gained 2 electrons. How many does it need to go up to 2? You only need 1 of it. And again, you have the same answer, the exact same answer, which is Na2SO4. Based on the crisscross method, you get this. Based on the LCM method, you get this. The goal is ionic compounds are uncharged. Ionic compounds are uncharged. It can contain ions that are charged, but the overall objective is cancel out the charges by thinking about how many multiple of the cations should cancel out the charges of however many multiples of the anion. Now I have the copper 2 plus here and the CO3 2 minus, which is copper 2 carbonate. Copper 2 refers to Cu2 plus, so copper 2 carbonate is Cu2 plus CO3 2 minus. The question now is, what ratio do they exist as? I could be thinking about the LCM, which is just 2, and this is already 2 plus, this is already 2 minus. So how many do you need? You just need one of these and one of these, so that is equal to CuCO3. If you decide to do the crisscross method, which has got nothing wrong with it, plus 2 charge minus 2 charge, when you do the crisscross, it's basically like a cross multiply thing. And what you do is you just bring down the number. You don't care about the charges. You just bring down the number on the charge. But you need to think, are they the simplest whole number ratio already? These are not the simplest whole number ratio. Lowest common multiple is to do with the lowest, oops, I don't know why I put 2 there. Should be 1 there. It should be the lowest common multiple. So we need the simplest ratio. Simplest ratio is going to be 1:1. This is the simplest whole number ratio. And that is why we only have 1:1, which is one of the copper 2 plus, one of the CO3 2 minus. Overall you get CuCO3, which I've gotten from the LCM method. Whichever way you like, just remember that it's something to do with balancing out the charges of the cation and anions to get to overall 0 charge, and is to do with not changing the constituent of the polyatomic ions, but instead maintaining the same kind of standard. All right. Magnesium nitrate, Mg2 plus, NO3 minus. So I hope you can get MgNO3 twice. The way you pronounce it is you need 2 of these to have -2 overall to cancel out +2. You pronounce this as MgNO3 twice, or Mg bracket NO3 twice. All right, twice because the bracketed NO3 nitrate ion, you have 2 of them. Ammonium sulfate is NH4 plus, SO4 2 minus. This is a +1, this is a -2, so it cannot be 1:1. Instead, what you have is I have 2 of the ammonium ion, 2 of the +1, and 1 of the SO4 2 minus, so I don't need to put the SO4 in the bracket. Okay, so I'm going a little bit faster now, but you should be able to catch through this. Hydrochloric acid is a standard formula, it's HCl, but you could think about it as H plus Cl minus. Only when it's aqueous, because they specifically told you it's an acid. When you have the molecule, it's stated in your syllabus as part of the 11 or 12 simple covalent molecules back in chemical structure and bonding topic. You know hydrogen chloride is not. Hydrogen chloride is a molecule. Hydrogen chloride is not ionic, it's a molecule. It's a gas at room temperature and pressure. It's a gas at 25 degrees Celsius. It has got covalent bonding. This is in your structure and bonding topic as part of the simple covalent molecule case study, specifically stated in the syllabus and any Cambridge endorsed textbook. Is a molecule does not conduct electricity, but it dissolves in water. This bond will break and you will get ionic solution, ions in solution, because this is a mixture. Aluminium carbonate, so I'll get Al2 from the CO3 2 minus, and then I will need CO3 in a bracket because I will need 3 of the CO3 2 minus. I can show you this one because this looks slightly complicated, but it's the same methodology. Bring down the numerical value of the charges. They are in the simplest ratio, so you need 2 of that, so 2 of that, 3 of these. I put in the bracket because it's 3 of the whole lots. I cannot change this whole lot. This thing come together, so I just put it in a bracket. And how many do I need? I need 3. I don't need to show the charges when I'm writing the formula. This is pronounced as Al2 bracket CO3 3 times. Okay, I said it again, Al2 bracket CO3 3 times. Okay, magnesium chloride, Mg2 plus Cl minus, so it's just MgCl2. potassium nitrate. So make sure you read the spelling carefully. It's just KNO3. Silver nitrate, silver form Ag plus ions, nitrate. So that's just AgNO3. Zinc, zinc form Zn2 plus cation. This is a very common chemistry, as you will later realize towards the middle of your O level or your IGCSE. You will discover through practical qualitative analysis of the cations. Zinc 2 plus is what zinc normally forms. And you have hydroxide. Hydroxide is OH minus. Again, we are looking at the whole thing being negatively charged, so we need to treat them as the whole thing in a bracket. Zinc hydroxide. I have a zinc 2 plus. I need 2 of the OH minus to balance out the zinc 2 plus. Iron 3 referred to Fe3 plus. Chloride is Cl minus. So there's FeCl3. Iron 2 is Fe2 plus. Nitrate is NO3 minus. So there's FeNO3 twice. This is IDE. It is not ITE or ATE. It's IDE. So it's N3 minus. There's magnesium nitrate. So you get Mg3 and 2. Make sure your numbers are subscripted. They're at the bottom, not on the same level, not the power. Okay, it's not a power. NH4 plus for ammonium. Phosphate with the ATE. So be very careful with the ATE. Is PO4 3 minus. So what you're gonna get is NH4 in a bracket, because I need 3 of these to balance out the 3 minus charge. So the whole lot has got 3, and I just have one lot of the PO4 3 minus. Without a bracket is one whole lot. Iron 3 hydroxide, Fe3 plus, OH minus. So I need 3 of the hydroxide to balance out the plus 3 charge. So this means, well, essentially what it means is like Fe3 plus, OH minus, OH minus, OH minus, minus 1, minus 2, minus 3, altogether balance out the plus 3. Ionic compounds do not have overall charge. Okay? Now this is the reverse of that exercise. From the formula, you should be able to tell what are the ion present, metal and non-metal, quite direct, except that you have O2 minus, you have 3 of them. And then this is Fe something, it has to be plus, and you have 2 of them. You have 2 of the iron cations, and you have 3 of these. The fact that you have 3 of these means 3 times minus 2 is minus 6. Therefore, you need this to be plus 6. But the plus 6 is for 2 times cations. So therefore, plus 6 over 2, which is plus 3 for each cation. So very clearly, this name is iron 3 oxide. You can also go forward, just like the previous exercise. Iron 3 plus, O2 minus, plus 3 minus 2. So you can do the crisscross. You just bring down the numerical value from the charges, but they swap positions. So what does this mean? This means you need 2 of the iron 3 plus, and you need 3 of the O2 minus. Plus 3 and plus 3 give you plus 6. Minus 2, minus 2, minus 2 give you minus 6. Overall, you get plus 6 plus minus 6 equal to 0. Compounds are uncharged. If there is anything you have learned from elements, compounds, mixture, atoms, molecules, ions, is that compounds are uncharged. You can have ionic compound, you can have covalent compound, they will be uncharged overall. But ionic compound contain ions that are charged. Anyway, on to the next one. This is a 2 there, this is a 1, so therefore it's a Pb2 plus, NO3 minus. I hope you can see that. This is called lead, but lead is from group 4. Lead is a group 4 element. It has got 4 outer shell electrons. Going down group 4, you go from carbon, which is a non-metal, graphite and diamond, and you go to becoming metal, which is lead and tin, further down the group. And because they are metal, they lose electrons and form cations. And the fact that lead is usually lead 2, such as this, we have to write them down because lead can also be lead 4, which is Pb4 plus. All right, so this is lead 2. NO3 minus is lead 2 nitrate. Well, NO3 minus is nitrate, so Pb bracket NO3 twice is lead 2 nitrate there. OH minus is what you call hydroxide. So this is calcium hydroxide. You have hydroxide anion. You have 2 of the OH minus to balance out the +2 of the calcium, which is a group 2 metal, as you should know the first 20 element. This is just silver chloride. I typically like to write silver 1 chloride just to indicate that silver is actually silver +1, but usually sometimes they write silver chloride, they will have been alright as well. This is going to be 2 of the Na+. So the way I know is because I'm experienced enough. Then group 1 form the Na+, and then the group 6 O2 oxygen atom form O2 minus. So what I have is sodium oxide. This is copper and this is sulfate, but this copper is a very special one. It's a copper 2+, so copper can also be copper 1. This one here is copper 2+ to balance out the SO4 2-. So this one has a name called copper 2 sulfate. If you miss the Roman numeral, you might make a huge mistake because it could also be copper 1. Now to the spelling of sulfate, some people are old school. I actually learned it as PHATE when I was in school, but these days internationally people are starting to adopt the FATE spelling. Both are equally accepted, but you should stick with one and know that the other one is the same thing, but you shouldn't mix and match your spelling for both, because you should have a standard that you follow through from the beginning until the end. So yes, I actually learned chemistry using this PHATE, but over the years, because I'm teaching students, so I've started to adopt the FATE as well as part of my standard, but I know they are the exact same thing. I'm just telling you, when you read questions, especially all the questions, or when you read all the textbook, they might still use PHATE. It means the same thing. Okay, this is K+, you have 2 of them, and you have CO3 2-, and you have 1 of them. This is called potassium carbonate. Make sure you can spell potassium properly as one of your first 20 element. This one is NH4+, you have 2 of it, and again you have CO3 2-. NH4+ is not ammonia. Ammonia is a molecule. NH3 is molecule. NH4+ is ion. NH4+ is ammonium ion. Okay, so be very careful of your vocabulary. When you spell the wrong thing, when you say the wrong thing, then they have different meaning from this point onward. Okay, this is potassium iodide, so it's K+ and I-. And the next one is something that a lot of people would spell incorrectly. Magnesium 2+, people have no problem spelling magnesium. It is the other one that people have problem with. F-, you have 2 of it. So F is pronounced as fluorine, Fluorion. This spelling is also given in periodic table, and you got to practice spelling it so that you don't make a mistake ever. Okay, the other one is called Fluorite Ion, and this thing is not given in periodic table, but you can get its -1 charge based on the fluorine atom wanting to get to a fully filled valence shell. So that is called fluorite ion. So fluorite, chloride, bromide, iodide, those are what you call halide ion. So this is halogen atom. This is halide with an IDE, ion. And you have another one. This is also fluorine, and then this is halogen molecule. Okay, so this is as the element that exists as the diatomic molecule, because a group 7 that exists as single covalently bonded atom, 7 + 1, they share just one of the outer shell electrons to form single covalent bond with itself. They are still single type of atom, only one type of atoms, even though they are molecules. Elements can be molecules, element can also be atoms, but all the group 17 elements that exist as this diatomic because 2 atoms covalently bonded together. Okay, now to the next part of the work. There are a couple of acids that you should know. Nitric acid is HNO3, hydrochloric acid, as I mentioned, was HCl, and sulfuric acid is H2SO4. calcium carbonate, Ca2 plus, CO3 2 minus. I should probably remind you that you can get it by knowing the ion. The nitrate ion come from nitric acid and the H plus, so you combine them as HNO3. This is CaCO3. Ammonia is a covalent molecule, so it's not ionic at all. So I can't do it in terms of ions. Be very careful. I can't do it in terms of this way because there are no ions in ammonia. Ammonia is a molecule. Ammonium is an ion. Okay. Sodium sulfate, Na plus, SO4 2 minus. Make sure you always check that your ions get balanced out. The plus one does not balance 2 minus. Okay. Aluminium sulfate, Al3 plus, SO4 2 minus. So I have Al2 and then bracket SO4 3 times. Magnesium chloride, so that is just MgCl2 because, well, you have Mg2 plus, Cl minus, plus 2 minus 1. You bring down the numerical value, so that means you have Mg2 plus, you have Cl minus, so you have 2 of the Cl minus, MgCl2. What's the next one? Ammonium is ammonium, NH4 plus. Sulfate is SO4 2 minus. The plus one do not cancel the minus 2 unless you have another one. Okay, this is basically what it means by NH4 plus, SO4 2 minus. If you do the crisscross method, where am I? Then you have plus 1 minus 2. Bring down the charges, but only the value. So you need 2 of these, 1 of these. You need 2 of these and 1 of these. Plus 1 is plus 2. Minus 2, there's nothing else, just minus 2. Overall, 0 charge because, because compounds are not charged. You need 2 of the ammonium and you have 1 of the sulfate. I don't need to put it in a bracket because I just have 1 lot of it. Methane again is a covalent compound and is one of the 11 or 12 covalent molecules, simple covalent molecules that you're supposed to be able to draw. It is not ionic at all. It's a simple covalent molecule. It is among the exercise that you're supposed to know how to do. Alright. They want you to simply state the element present. So you got hydrogen, you got nitrogen, you got oxygen. You got 1 hydrogen, you got 1 nitrogen, and you have 3 oxygen. 1, 1, and 3. Here, calcium carbonate, you have calcium, carbon, and oxygen. You have 1 calcium because there's no number stated there. You have 1 carbon, and you have 3 oxygen. As the subscript there shows 3 oxygen, 1 carbon. They don't show the 1. It means there's 1. NH3 has nitrogen and hydrogen. Should try and use a different color. Nitrogen and hydrogen. So it doesn't show the number there. Means there's 1 nitrogen. There's a number there, 3 hydrogen, so 3 hydrogen. There are 3 elements here. There's sodium, sulfur, and oxygen. Sodium, sulfur, and oxygen. So there's 4 oxygen, there's 1 sulfur, and there's 2 sodium. There are 3 elements. There are actually 4 elements here, not 3. Aluminium, sulfur, and oxygen. This is a tricky one. Aluminium is easy, there's 2. Now, you have SO4 2 minus, bracket 3 times. What does the 3 times mean again? What does the 3 times mean? It means SO4 2 minus, SO4 2 minus, SO4 2 minus. Total, you have 3 sulfur, because inside the bracket you have 1 sulfur. Total times 3, you have 3 sulfur. Okay, so be very careful. 3 is the outside one. Inside the bracket, there's 1 sulfur, so altogether, there are 3 sulfur. Let's do the oxygen. Inside the bracket, you have 4 oxygen. So 4 oxygen inside the bracket, but the whole thing, you have 3 of them. So in 1 unit, you have 4 oxygen. And now in 3 units, you have 4 and 4. So 4 times 3, which is 12 oxygen atoms altogether. Okay? On to the next one, magnesium and chlorine. This is a slightly easy one. 1 magnesium and 2 chlorine. And here, what do we have? We actually have 4 elements here, okay? This one is a bit tricky. There are actually 4 elements here. There's nitrogen, hydrogen, and I just want to put in another line there. And there's sulfur and oxygen. I should try and use a different color for this, just to try and make them stand out. Let's put red. Oops, no, red. Okay. So the nitrogen there are two lots of the ammonium. So inside the bracket, there's one nitrogen, the number stated there. And then there's a 2 outside the bracket, the whole thing. So there's 2 lots of it, 1 and 2. Okay, so that's why it's multiplied by 2. Hydrogen inside the whole unit, inside one unit, you have 4 hydrogen. But you have 2 of them. You have 2 of these, just like this. 2 there means 2 of these. So 4 there and 4 there. 4 times 2. It's going to be 8. Your sulfur there has just 1. Your oxygen there has just 4. So oxygen is just 4. Sulfur is just 1. Now to CH4, this is slightly straightforward. 1 carbon, 4 hydrogen there. On to the next bit of the exercise, we need to calculate relative molecular masses. Relative molecular mass has a definition. It is the sum of relative atomic masses. Relative atomic masses. For there's an incomplete one as well. It's the sum of the relative atomic mass, which is given in the data booklet. Data booklet is A level, which is given in the periodic table for free for all level chemistry as well as combined science chemistry. So you're given the periodic table. It states their relative atomic mass. So we have to use the relative atomic mass, sum them up for each of the atom that we have present to calculate relative molecular mass. There's a space for working here, but if you are a pure science student, most likely you just need to know how to do them initially, and then you should be very careful when you press the calculator, and you should be very fast when you press the calculator as well. You need to know the calculator, not the calculator know you. Okay, I'll just write down the working for the first one. There is 2 hydrogen. The relative atomic mass of hydrogen is 1 multiplied by 2. You can do 2 hydrogen multiplied by the relative atomic mass. It's going to give you the exact same answer. Alright, so it's how many multiples you have, how many atoms of what you have, times by the relative atomic mass. I have 1 sulfur. The sulfur shows me relative atomic mass of 32. I have 4 oxygen. Each one has a relative atomic mass of 16. Pop that into the calculator. So 2 plus 32 plus 16 times 4, I get 98. Alright, so I'm just going to verbally do this. So magnesium is 24 plus I have 2 chlorine, so 35.5 times 2. Okay, so I get 95. Now I'll show the working just in case you didn't catch the bit. 1 times 24, the mass, the relative atomic mass of 1 magnesium, and I have 1 magnesium, so 1 times 24. Sum up, total up, add up. Okay, relative atomic mass. I have 2 chlorine, each of which is 35.5, given the given in the periodic table. So 95 is there. Calcium carbonate. So there's 40 times 1 plus 12 times 1 plus 16 times 3. And you should get 100 because I've done this a lot of times throughout my entire life. The next one is a tricky thing. What does the NH4 twice mean? It means you have NH4 plus, NH4 plus, and then you have CO3 2 minus. Okay, so what I'm going to do is I'll put a 2 outside for the whole multiple. 2 lots of it, 2 lots of the whole thing, so 2 times the whole thing. Now this inside is for the inside. What is inside? I have 14 for the mass of 1 nitrogen times 1 plus 1 times 4 because I have 4 hydrogen, each of which is 1, then close bracket. This is inside that bracket, multiplied by 2, which is outside the bracket, 2 times the whole thing. Do this on the calculator first, then multiply by 2, alright? And then I have to add the carbonate. So I have 12 times 1 for carbon, and I have 3 times 16 for the oxygen. So 14 times 1 plus 4 times 1, and then I get 18. 18 times 2 is 36, plus 12 times 1 plus 16 times 3, I get 96. Okay, the next one I have 23 for 1 sodium, but I have 2 sodium, and I have 16 for 1 oxygen, so 16 times 1. So I get 62 there. CCl4, 12 times 1 plus 35.5 times 4. I think the next few examples I'll probably just press on my calculator. Lead, I don't have lead relative atomic mass on top of my head. So what I'll do is, let's have a look at periodic table. Lead is in group 4, is Pb, is 207. So 207 for lead, plus 12 times 1. Well, actually there should be times by 1 just to be safe. And then 16 times 3, so 207 times 1 plus 12 times 1 plus 16 times 3, I get 267. Iron 3 nitrate, I hope you can realize that this is iron 3 nitrate, this is not iron 2 nitrate. You should be able to go forward and backward. And so I'm just going to press my calculator. So I have 56 times 1 plus 3 times bracket, make sure you use bracket, 14 times 1 because I'm inside the bracket, plus 3 times 16. Now I close bracket and it already multiplied by the 3 that I had outside just now. You must have a certain standard when you do this thing. If you are careless, you will mess up. If you are careless, write them down and see it for yourself until you can do it very quickly without being careless. All right, so I'm just writing them down now so that you can see what's going on. Okay, zinc sulfate, so zinc has a mass of 65 and then multiply by 1 plus 32 times 1 plus 16 times 4. And I get 161. Lithium, this is lithium nitrate, so lithium is 3 times 1 plus 14 times 1 plus 16 times 3. I get 65. Did I do that correctly? Let me just double check. Yep, 65 there. Okay. Now, in terms of the following substances, sodium chloride, Na plus Cl minus. So that is your classic ionic compound case study from structure and bonding. Ammonium sulfate, getting to be very popular now. NH4 plus SO4 2 minus. Do not combine the formula straight away. You should be able to realize from the charges you need 2 of these and 1 of these. And oxygen is O2. This is your structure and bonding, around 11 or 12 simple covalent molecules that you're supposed to know the structure of. Okay, I can show you. It's like that. I can also show you dot and cross like that. Like that. Make sure when you draw dot and cross, you complete all the other electrons and not just the bond. All right. In terms of relative molecular masses, there's just 16 times 2. I get 32. And then 23 for sodium, 23 times 1 plus 35.5 times 1. I get 58.5. The next one is ammonium sulfate. There's a similar exercise just now. Put the 2 outside, and now I have 14 times 1. Plus 4 times 1 for inside the bracket, and I have 2 of them, so 2 times the whole thing, and then I have plus 32 times 1 plus 16 times 4 for the sulfate. So I'll do 14 times 1 first, and then I'll add 4, so I've done this bracket, then multiply by 2, I'm done this part, then plus 32 times 1 plus 16 times 4, and I get 132. Let me just double check my calculation. 14 plus 4 is 18 times 2 plus 32 plus 16 times 4. Yep, I got 132. So that's it for this tutorial video. I mean, fairly quick one just to go through formulas. You should have ideally already have a table of the common cations and anions that you can use to generate a lot of these formulas, and you should be more than comfortable understanding what each of these numbers mean in terms of how to calculate the relative molecular masses, in terms of just adding up the relative atomic masses. Especially be careful with the use of bracket. Also use bracket to see it. If you are not comfortable putting them straight into your calculator, make sure you write them down initially to see it until you become an expert and you can press them on the calculator without any mistake. Alright, so that's it for this tutorial video. Don't forget to subscribe to the channel and share the channel widely with all your friends, your chat and study group, your juniors and seniors, and everyone else you think the channel might be useful for. And follow me at ptet.chemistry, follow me at ptet.chemistry on Instagram, Facebook and Twitter for all the latest updates, and I'll see you in the next tutorial video. Thank you for watching.